This is the 3D model of the spectroscope slit arrangement, just to sort of try and explain a little bit about what's going on. Let me just point out the individual components. We've got two slit blades. One is this little unit here with the two holes in it, which is the blade which that we made last time, and with the polished edge. And the other slit blade is this one here, which is a bit longer, and it has two holes here, and it's mounted onto a separate component. The way in which the slit itself is the gap between these two blades here, and the light passes through there, and you can see behind there's a hole which allows the light to pass. If I just turn this model over, you can see the light will come through that slit in the middle and pass through this hole. So the rest of the spectroscope is sitting where we're looking, but the actual sunlight will hit, or starlight or whatever it is, will hit the slit from this side. Now, the way that this system is designed to work is that the goal is to try and make sure that the spectroscope slit opens up symmetrically about the optical axis. The optical axis should be right in the middle of that slit. The trick is going to be moving these two slits apart about that central line. Now, the method of doing that is really sort of designed around the fact that each slit blade is mounted to a separate carriage. So we've got this carriage here, which has one slit on it, which I'm calling the inner carriage, and the outer carriage, which is this pale blue section with the other longer slit mounted to it, is what I'm calling the outer carriage. So the inner carriage and the outer carriage are in fact separate. The way that they move is that these two russet red colour bits here are actually springs. They're pieces of spring stainless steel, and they're clamped and mounted, and I'll show you the actual physical thing when I get it done, but they're actually mounted to the edges. So you can see on this outside bit here, this russet piece is mounted on here, and I haven't got them on the drawing here, but they will be the same on the other end as well. So what that means is that, what that means is that if I were to put pressure on the end of here, these blades here, these spring steel blades, will flex, and the whole carriage will move in the direction I push it. It will maintain its squareness because obviously it's a big broad spring, but it will move. Now, the inner carriage is on its own set of springs. So here's one of them, which is mounted onto here, and the other one is not shown, but will be mounted on the other end. So that also is on two springs. So this now can move backwards and forwards. This inner carriage can move backwards and forwards about, sorry, it's jumping around a bit, can move backwards and forwards about those, on those two springs. Now, because these two springs are identical, they'll have exactly the same amount of springiness, force. If I push and pull on these equally, then these two slits will move apart, and they should move apart an identical amount, and thus maintain the optical axis down the center of the slit. So with very fine movement in that direction and that direction, I can separate and obviously bring back together the slits. Now, the idea is that in the quiescent state, with the springs in their upright positions, the slit will touch, or that's pretty much how I'm going to set it up, so that the two blades will be brought together and they will actually touch. So as soon as I impart any pressure on these two springs, these spring sections, then separation will occur, and it will maintain its parallelness, and it will also maintain the optical axis down the middle of the slit. Now, that's the plan. So this is the drawing, or rather this is the 3D model of it. From that, in Onshape, which I'm using, I've produced a number of engineering drawings in order to help me make those. So this is the part we're going to be making next, so let's get into the workshop and get cracking with that. Hello! Sherbet and I just working in the workshop, aren't we, Sherby? He's just making sure it smells okay. But this is the carriage, the inner carriage, which holds one of the blades. And last night we made these little clamping bars, or I made them. Sherbet didn't have much to do with it. This one's actually mounted, so you can see how it goes on. The spring will be trapped between that plate and the actual carriage itself and come out this direction, and the same on the other side. I've left this one off so you can see what they look like. That goes on in the same way. So what we've got to do now, what we're doing tonight, is the outer carriage. So let me just get the inner carriage. This is obviously a different scale, but the inner carriage is going to sit inside this one here, and that'll move up and down like that, and the outer one will move up and down like that. And there's a blade, one of the blades is on this carriage and the other blade is mounted on that carriage, so the two blades will separate and go together. So this is what we're making here. It's got to have some holes in the ends as well, for these holes here for the springs for it as well, because this is on the same type of spring. So that's what we're doing tonight. Right, there's the basic piece. I'm just draw filing these edges just to make them a nice smooth edge. It's just a case of knocking off the any sort of slight burr there is on there. This is only the prototype, so I'm not finishing this absolutely immaculately, but I want it to be obviously I don't want it to be sharp, but I want it to also go into the vise properly when I come to do the next bit. Don't want it to be inaccurate because it's fouled slightly. I think we've nearly got it there. I didn't do that very methodically, so I've lost count of where I am, but that doesn't look like it's been done yet. I mean, the milling machine doesn't leave much of a burr, but just to be safe, I'll just draw a file like this, and it does give it a slightly nicer appearance. As a sort of poor man's chamfer, really. But and then the corners, I'll just knock the edge off the corner like that. Again, that's just really more to stop it being sharp. There we go. So all we've got to do now is, looking at if you can see the diagram there, is cut the hole out the middle and drill those two holes. So back to the milling machine, and we'll get that sorted. That doesn't look square. I'm just going to check it. I'm just going to check it for square. There's my this is just a cast iron, it's a tool steel angle, but I have checked this with my all my gadgets, and it's pretty much straight within a tenth all the way across the face. So for this it's absolutely fine. So I'm just going to hold it up against there, and yeah, I can see light coming through there. That side is parallel to that, but yeah, the sides are just a cock hair out. So I mean, that's from milling like this, probably deflection in the tool and all that. I should have really done it probably end on, but this is not. These aren't critical dimensions, so we should be okay. The hole in the middle is a little bit more critical, but I'm doing that all with as long as I tram that in, my vice is trammed in, which it is. We should get that cut out square out the middle. It should be fine. I'm sorry, forgot to include you in the action, but there we go. I've cut the hole out. So this carriage now goes inside that carriage there and slides up and down like this, and that goes, and this is mounted on springs on the inside here. So basically that's on springs like that, and this is on springs like that. So they're both sprung independently of each other, so they can both move freely in that plane or that. That's basically how it's designed to work. So all I've got to do with that now is drill and tap a couple of 3mm holes for the other slip blade to rest on. But there you go. That came out okay. I did actually overshoot slightly on this corner here, but as I say, it easily done. Just wound the handle the wrong way once, but I was just stopping about probably about just under 1/2 mm short as I was going around, and then for the finishing cut I just went to but it was when I was doing the finishing cut I wound the handle the wrong way, because I was just looking at the finish being lovely and took my eye off the ball. But that's how it goes. But anyway, it looks fine, and it'll work absolutely fine. So next step probably is to make the actual base unit, which where the springs all mount, and it holds the whole thing together, and holds the mechanism for moving the slit carriages backwards and forwards. There's 3mm. Not putting too much pressure on here because I've got it clamped this way off. Now because we clamped it the other way, it was going to, I was going to drill the parallel, so I had to do it that way. So that's the 2.5mm hole for the tap, and here's my tap. So let's get my tap in. Okay, and slow that right down. Get that to a sort of sensible speed. Right, get it ready. In she goes. Oops. Back. Ooh. Sometimes you don't quite get this. Jacob's chuck sometimes doesn't go in properly. Oh no! There we go. I'm going to go back in again because that's done it. There we go. Just 3mm hole through there, and what we've got to do now is flip it on its end and do the 3mm holes through here for the clamps. That's down on the new hammer. Thank you very much, Mark Williamson, for buying me this little hammer, this little mallet I should say. My intention is on this mallet is to make a brass, and maybe if I can get hold of some lead would probably last 2 seconds, but copper or brass, make one of these for this. At the moment I'm just using the plastic inserts that are in there, but it's a little bit handier to get in to tap things down like that, so thanks for that, Mark. Oh, it's popped already, sorry, I wasn't watching properly. So there it touches. Once it touches, pop it, there it goes. So that's going in the X direction, so 0x. I'm just going to check it. I do tend to just check it, just to make sure. There you go, that's 0. So now we do the other end. That's the other end. Down with the quill. Okay, watch it line up. There it's lining up, and pop. There we go. So midpoint. So 0 was the first end, and then 41.57 is the other end. So all I have to do now is do midpoint X, and that divides it by 2. So now I can wind. If I wind back to 0 here. There you can see that we're right in the middle of the work now, because I've divided that by 2. So I'm just going to do the same again for the other axis. So we get on centre. So whoops. So get it to touch. It's touching and now it popped out. So I'm going to 0 it there. I'm just going to double check. So in again. Yeah, pop, and that's 0. So lift the quill up, go to the other side, and do the same. So wind out until it touches, and then pop. There we are. Midpoint. Y, and now I've got. If I wind back to 0, let's just, oops, wrong way. Wind back to 0. Oops, dry over by. There we go. That is now, as you can see, I'll just stop the spindle. That is now right in the middle. So just change out for my spotting drill. And you'll see, there you go, that's right bang in the middle. So all we need to do now is go 250 thou. Oh no, we're not, hang on a minute, it's going to old money. Inch. So 250 thou. Just go over slightly to. 250. There we are. So that's 250, and that's where the hole goes. So that's the first hole. Put a spot on it. That looks good. And then now I'm going to do clearance on this so that it's screwed from the outside onto the backing plate. Just got to swap it around and do the other end. So here's the spectroscope slit assembly coming along quite nicely now. The bits that are here, this is the outer carriage here, and this is the inner carriage, and in fact I've got the test slit on the carriage there, mounted on this carriage now. This carriage will move up and down like that. It's going to have springs which are trapped between the edge here and this bar, and there's another edge and bar there, as you can see. This carriage here will have a longer slip blade, so that where this slip blade ends here, this one will extend the other slip blade, which will come across here. The light goes down through that hole there. This second slit will be mounted onto the outer carriage, so it'll be about this sort of wide up to here, and that will be attached to this outer carriage. These are the M3 screws which are going to be used. I've got to make some clamps, so this is the material that I made the other clamps from. I've just got to cut two more clamps with clamp bars which are going to go down here. And this carriage will also be on springs mounted about these 2 points. So this will be on springs and this will be on springs, and the springs are going to be identical on both sides, so the amount of spring tension will be nigh on identical. That means that when you push and pull them both, they will both move an equal amount in either direction. Therefore the slit itself, which will be here, will remain central to the optical centre line. This is one of the problems with spectroscope slits, is that if in a lot of cases one of the slits is stationary and the other one moves, and therefore the slit itself moves off the centre line. Whereas with this design, the centre line remains. The two slits move on either side of the centre line in equal proportions, because they're both obviously, you know, Newton's law of motion and all that. The forces are equal and opposite, therefore they both move equal amounts in either direction. So that's the basis of how this mechanism works. So no fancy hinges, no dovetails, no difficult things to machine particularly. You just got to make sure that this is all square and true, and the holes are all in the right places, but other than that it's nothing particularly rocket science. So I've just got to make the base that they go onto now, and I'm going to make that from steel. I've got some nice tool steel which I'm going to make that from. I'm only making that because this is actually going to be the piece itself is going to be just two piers, this one here and this one here, with an underlying plate, and the underlying plate will have all of the other mechanism mounted to it, which will adjust the spring and hold the in the first instance hold the micrometer barrel and such like. So these two piers which stick out from the side, which are going to form the mounting points for the springs, need to be pretty stiff, obviously, for obvious reasons. So I'm going to make that out of a bit of I think it's about well, in fact it's here. Here's some steel that I've got here. So I'm not sure how thick it is. It's about 6mm, but it's well strong. I mean, it's going to be super strong for what we're talking about, and relatively nice to machine. So there you go.